All right, hey Dan, welcome to the Greco PumpCast. I am Brendon Forrest, host of the PumpCast. So today, just wanted to jump right into it. We're going to be talking about metallic diaphragm pumps. So the last time we talked about plastic diaphragm pumps. So we wanted to hit the other side of the coin and let's talk about metal. So how metal is used and all that good stuff. So let's just do a quick description of what metals we typically find in a metal diaphragm pump.
Absolutely. Thanks for having me. Appreciate it. When we talk about metal pumps, what we're talking about is generally four different types. We're talking about aluminum, what by far the most common, makes up about 70% of the diaphragm pump market right now. It's inexpensive, durable, light. It works with a wide range of materials. Then we start looking at stainless steel. Stainless steel has, then again, a little bit more abrasion resistance, higher temperature resistance. Costs considerably more than aluminum, so you don't see it nearly as much in the marketplace. We look at cast iron, ductile iron as it's sometimes known. Cast is more abrasive resistant than aluminum. A little bit more expensive. What you're going to see that is generally in wastewater applications, a lot of particulate, a lot of different solid type material. And last, we talk about a specific alloy called Hastelloy. Not very common in diaphragm pumps, mainly for the reason because it's so expensive. It can be very cost prohibitive. Depending on the size of the pump, you're looking at anywhere from 3 to 5, 6 times more expensive than stainless, and that's generally due to the high nickel content in the material. It does allow it to have a little bit more pH resistance, a little more chemical resistance than even a stainless, but you don't run into that a whole lot.
All right, so generally speaking, what are these metal pumps used to transfer? Maybe we could talk about from each different category,
Sure.
Aluminum, stainless, cast, and Hastelloy.
Yep, so we can kind of lump aluminum and cast iron in together because they're generally going to be used for pumping a highly abrasive material. We look at them from we'll use the term generic transfer, generally because, again, they are inexpensive. If you look at them even versus a plastic pump, aluminum and cast iron are going to be the cheapest alternatives out there. So you see them in the vast majority of the applications. Aluminum a lot in petroleum-based because there's nothing really there. It's a neutral material. It's just straight transfer. Wastewater applications. We move into stainless. Stainless you're going to start to see in some chemical. Generally, if you've got abrasives present in, let's call it medium concentration chemical, we're never going to see them competing directly with the plastics because they don't have that chemical resistance. There's still some corrosive applications that they don't do well in. And then we move again, we were talking about Hastelloy. We will see Hastelloy in high concentration chemical, but you don't run into that a whole lot again because it is very cost prohibitive. And you don't run into high concentration chemical where you have a lot of abrasives present. Generally, high concentration chemical is on the process side, so you're not going to see a lot of abrasive.
On chemical waste, a lot of times that chemical gets diluted, and so you can see. Do you ever see like a metal pump used where the chemical compatibility is maybe not as great, but it's on the waste side? So it's diluted chemical, so it's got a little bit more compatibility, but it's also dealing with abrasives. Is that something that we see commonly with metal pumps?
Yeah, good point. So you will see metal pumps on the waste side of process. So in a chemical plant, you may see some in waste sumps, overflow applications where the chemical is so dilute as to be less than 5%. It's mostly water. But being in a sump application, you're going to see a lot of particulate, everything from sand to rocks. So you will see some of that as well.
So what should we use metal pumps to transfer?
Again, if we look back at it, we're going to be using metal pumps generally for petroleum-based products, dilute chemical, wastewater, because it is so full of particulate. And you can really look at an aluminum or even a cast iron pump to just about transfer anything that is not chemical. And people lean toward that because of the low cost. When you compare an aluminum pump to even a polypropylene pump, they're half the cost. So very general transfer. When you go in the field and see a pump that somebody has on a shelf to pump, let's say, anything, it's going to be an aluminum pump because they use it for anything and everything generally.
All right, so we've been talking about the fluid, the fluid material with the metals, but we'd like to talk about some of the internal components that we see with these metal pumps. And so, what is the most common that we see? Maybe talk about like the waste and then petroleum and that sort of thing.
Yeah. So if we look at a wastewater application, we're generally talking about two different internal materials. It's going to be a sanaprene or a geolast. Very abrasion resistant, very inexpensive, and the cycle life is almost infinity. They just work. They pump forever. And in those applications, people want that durability and they want that low cost. When we start moving into petroleum, we're going to be starting to look at your Bunas, Hytril. We'll even look at Delrin acetoplastic for the internals on those pumps, because we do start to need some what we would call chemical resistance. Petroleum isn't water, obviously, so we do need some resistance to chemical, and we'll start looking at those three materials because they are very chemically or very petroleum resistant. I'm sorry.
When would you ever use some of the metallic internal components?
So if we start looking at stainless steel balls and seats, we're definitely going to be looking at very, very highly abrasive material. We'll also start looking at heavy material as well. So think like a latex paint, which these really do well in, simply because, again, it's water-based, so you can pump them with just about anything. But the material is thick, so you need a weightier ball to fall back through, because we're still using gravity to get back down to the ball check. When we start looking at stainless steel and Hastelloy pumps, we're going to be looking at those Teflons, those Viton materials, because we do need the chemical resistance at that point.
I'm assuming when you start getting into the metallic internals with the balls and seats, those pumps can get pretty loud.
They do get fairly loud. Yeah, good point. I mean, metal on metal is loud, but you're only going to be specifying that in applications that require it, and you're just going to have to deal with the noise. If you need it, you need it. And it does boil down to cost again. When you're on the aluminum side and the cast iron side of these pumps, cost is always an issue. People want low cost. You're not going to be specifying stainless balls and seats because they're quite expensive.
All right, so let's talk about some of the pros and cons of a metal diaphragm pump. So what are the pros of going with metallic versus plastic?
Sure. So number one is going to be durability. And again, it goes back to that abrasion resistance. So metal, much more abrasion resistant than plastic. People lean toward durability. In the case of aluminum and cast iron, again, it's cost. The pumps are inexpensive. They do what you need a diaphragm pump to do and nothing more. Depending on the material chosen, they do fit a wide variety of applications. Could be that petroleum, could be that mild chemical, could be wastewater. They fit just a very broad range, and that's why people do lean toward metallic pumps.
When people are specifying pumps, are they looking at usually like one specific application when they purchase a pump, or is there sometimes where they're looking at multiple different applications and need a pump to do multiple things?
Great question. So I think with aluminum in particular, people will buy a pump that is kind of their catch-all pump. They know that they can pump some very dilute chemical with it. They know that they can pump petroleum, provided the internals are specified properly, and they'll pump just about any type of waste. When you start getting into stainless and Hastelloy, simply because of cost, you're usually in one application only. It's going to be maybe something chemical, or it's going to be maybe something very, very hot. In the case of stainless steel, being a little more temperature resistant than aluminum, and Hastelloy is Hastelloy. I mean, you've simply specified that pump because of high concentrated chemicals with some abrasive material present.
Cool. So on the con side, we've definitely hit the cost thing, especially with stainless steel and Hastelloy. What other cons are there for a metallic pump?
So weight is always going to be something versus a plastic pump. They're going to be heavier. They're going to be a little more unwieldy, especially when you start getting into 1.5, 2-inch, 3-inch pumps. They're not inherently portable just because of the weight. And they're generally less chemically resistant than plastic pumps. You know, the plastics and the polymers were designed for one specific reason, and that was for chemical resistance. And no matter what you do, even with a Hastelloy still isn't going to compare to a Kynar or a Calores or something like that.
All right. So what are some of the quality considerations we need to be aware of when selecting a metallic pump, especially when we're looking at different manufacturers now?
Sure. So the number one thing you want to look at is making sure that you're sourcing quality castings. Castings have varying degrees of porosity. Porosity is the absolute dearth of a metallic pump, because as material is cavitating through the pump, that becomes an abrasive material. You want a pump that is very consistent wall thickness. That's really probably the number one thing. You want to make sure your castings that you're sourcing are very, very high quality. And there are a lot of castings out there, especially in what I would call like knockoff pumps. They are not high quality castings. There's a lot of pores. The porosity is extreme, and those pumps just don't hold up over time. What also is a big deal is a coating on a pump. Generally speaking, you have to put a coating on a metallic pump to mitigate corrosion. With our aluminum pumps, we powder coat our pumps. We are the only manufacturer that is going to the expense of powder coating. There are a handful out there that are liquid painting. There are some that are just supplying their pumps bare. When it comes to your stainless and your Hastelloys, quality passivation. You need coating even on a stainless steel and Hastelloy pump. There's no such thing as true stainless. You have to have something on it. We passivate all of our stainless and Hastelloy as well.
Looking at, you're talking about high quality castings. Is there a way to tell if a casting was high quality just looking at the pump, or is that you just need to know the manufacturer does high quality castings?
Great question. From the outside, very difficult to tell. We know that there are some knockoff brands out there, some lower quality brands that, especially with aluminum, they're painting their pumps just to cover up the low quality casting. There really isn't a way. You just need to make sure you're partnering with a high quality partner. Absolutely, you see it in the cost. Your higher dollar pumps are the better pumps, and it all boils. That cost is coming from quality casting.
Okay. So we talked about this with plastic pumps for environmental and sustainability considerations. So I want to have the same conversation with you on metal pumps. So what do we need to be looking at for environmental and safety or sustainability considerations?
So a lot of it is very similar. I mean, you want to partner as a customer with a company that is doing as much actual manufacturing as possible, not simply assembly. And the reason for that is that allows a company like Graco, we control everything. We control the processes, we control the quality. To sum it up, a true manufacturer of pump allows us to control that quality. And when you control everything from design to machining, it allows us to minimize waste, to improve quality, and to reduce the amount of energy that we consume. And this is all going back to achieving our sustainability goals. It's all about sustainability and being able to control those processes and such. That's a big part of it because it allows us to minimize the amount of waste. It allows us to minimize the amount of labor involved, everything. And being that true manufacturing partner is key. And we're about the only one left.
I'd also say probably at the end user level too, you buy a higher quality pump, a Graco or a high quality competitive pump. That pump's probably going to last a lot longer and it's built to be repaired, correct? Whereas if you start buying those knockoff cheaper pumps, you're throwing those pumps away. And so that's just material that's just going into the dump, right?
Great point. When you're partnering with a quality partner, and again, we're not the only one. You made a great point with some of the better competitors out there. The pumps were designed to run for 10 years, 15 years, and just be repaired as required. And you're not seeing that from the low-end competition right now. And let's face it, all of these pumps are expensive. Nobody is giving them away. If the pump isn't repairable, it ends up in the landfill. And being able to repair the pump over the course of 10, 12, 15 years definitely helps the end user achieve their sustainability goals as well.
Yeah, it's pretty incredible. A lot of the pictures I see from end users on LinkedIn, 15, 20-year-old pumps, and a lot of them like Australia mines or, in a factory somewhere and it's just caked with material, but it's still pumping away after 2 decades. It's crazy.
We have diaphragm pumps in the field that are 30 years old right now. And end users love the fact that they can still get repair parts for them. The pump is still doing exactly what it was designed to do. That to me, that spells sustainability.
Awesome. Well, Dan, do you have any parting words before we wrap up today?
I really don't. I appreciate the time, and yeah, that's about it. Thank you for having me.
Visit us at Graco.com or follow us on LinkedIn to hear more conversation we're going to have on both the industrial and the sanitary side. With that, that's all we had. So have a good one. Bye.